real numbers, basic concepts which are used to 9th class and 10th class. So in number system, real numbers is very important thing. So first, in previously you learned natural numbers, whole numbers, integers. So natural number set. So the set of natural numbers are denoted with capital N, and the elements in N are 1, 2, 3, 4, 5 up to so on. So daily counting numbers are called natural numbers. Next, whole numbers. If you are taking whole numbers, so whole numbers are denoted with W. So these natural numbers along with 0. I am taking one more number 0, 1, 2, 3, 4 up to so on. These are whole numbers. Next, integers. So integers we are denoted with either I or Z. So capital I or capital Z. So the integers are positive numbers, negative numbers. So 0, +1, +2, +3 up to so on. -1, -2, -3 up to so on. So simply I am taking 0, +1, -1, +or -1, +2, -2, +or -2, +3, -3, +or -3, like this. So these numbers are called integers. Next, rational numbers. Rational numbers. So rational numbers are denoted with capital Q, and the numbers which are in the form of P by Q. The numbers which are in the form of P by Q, where here P comma Q are integers. P comma Q are integers. Belong to that means integers. P comma Q are integers. And the denominator Q not equal to 0. The denominator Q not equal to 0. So if the numbers are in this form, those are called rational numbers. For example, 1 by 2, 3 by 5, -4 by 7, 9 by 25. So like these numbers are called rational numbers. Next, so these are rational numbers. If we are taking a number 0, so 0 is not a natural number, but it is a whole number, and it is also integer. Next, so 0 can be written as 0 by somewhat, whatever, 5, 0 by 99, like that. So it is in the form of P by Q. Denominator won't be equal to 0, but numerator may be equal to 0. So 0 can be represented as rational number. 0 is a rational number. So if we are taking any natural number, we can take a denominator with 1. For example, I am taking a natural number 5. 5 can be written as 5 by 1. 5 and 1 are integers. So 5 by 1 equal to 5, which is a rational number. So every natural number is a rational number. Every integer is a rational number. Every whole number is a rational number. Next, real numbers. The numbers which lies between -infinity to +infinity. So the least number is -infinity. The greatest number is +infinity. So we are taking whatever the numbers. So those are real numbers. Next, irrational numbers. Irrational numbers. So before discussing irrational number, rational number, which is in the form of P by Q, P comma Q are integers and Q not equal to 0. P comma Q are integers and Q not equal to 0. The numbers which are in the form of P by Q are called rational number. So either we are converting P by Q form to decimal form. Every rational number, when we are converting P by Q form to decimal form, either it is terminating or non-terminating recurring decimal. So if we are taking, for example, 4 by 5, if we are dividing 4 with 5, so 4 is less than 5, so I am taking 4 point, so immediately I am keeping 0. 5 into 8, 40, 0. So it is terminated because the remainder 0 came, so it is stopped here. So 4 by 5 equal to 0.8. Next 16 by 25. So if we are taking 16 by 25, so 0 point, so 0, 25 into 0, 20, 0, 16, 160. So if we are taking point, we are keeping 0. 25 into 6, 150, 10, 100, 25 into 4, 100. So 0 came, so we stopped here. So this is equal to 0.64. So 0.64, this is also terminating. For example, 22 by 9 I am taking. So if we are dividing 22 by 9, 9 into 2, 18, 4, point we are taking 0, 9 into 4, 36, 4, again 0, 9 into 4, 36, again 4, so 0, 9 into 4, 36, again. So this process is continuous indefinitely. So it won't stop at anywhere. So if we are observing 2.444 up to so on, we can simply write it as 2.4 bar. So if we dividing a fraction, converting into decimal form, either it is terminating or non-terminating recurring decimal. So 0.64 it is terminated, 0.8 it is terminated, but 0.44444 up to so on, it is continuously, it won't end with anywhere. So 444 continuously, I want to write 4 bar. 4 bar means 4444 like that. So one more, 8 by 11 I want to take 8, 11, 0 points, keeping 0, 11 into 7, 77, 3, 30, 11 into 2, 22, 8, 11 into 7, 77, 3, 30, 11 into 2, 22, 8. So here the reminders are 8 and 3 will come. So this is equal to 0.72 bar, 0.72, like this. So 0.72 bar is for 72. Okay, so this one. So 8 by 11 we can write it as 0.72 bar. So 8 by 11, 8 is integer, 11 is also integer, so it is rational number. While we are converting this rational number into decimal form, we got 0.72 bar. It is non-terminating, but it is repeating. So 72 after 72 after 72, like this it will be continuous. Okay, so when we are converting a rational number into decimal form, either it is terminating or non-terminating recurring decimal. If we are observing, so 0.8 it is terminating, 0.64 it is terminating, so 22 by 9 0.244, so this is 2.24 bar, so it is non-terminating recurring. 0.72 bar, so bar is for 72, it is not terminating but it is recurring. Okay, so every rational number while we are converting into decimal form, either it is terminating or recurring. Okay, so the part which is repeated, which part is repeated is called a period. So here the period of this one is 4, the period of this one is 72. The number of digits in the period is called periodicity. So if you are observing how many digits are repeating, only one digit, 4 is repeating. So this periodicity is equal to 1. So if we observe this one, what is repeating? 72, 72, 72, 72 like this. So 72. So is the period. So periodicity equal to 2. So with the help of period and periodicity, we can convert a decimal form to P by Q form. Next, these numbers are terminating. These numbers are not terminating but recurring. The numbers which are neither terminating nor recurring are called irrational numbers. For example, 3.25349372 up to so on. So in this, nothing will be continuously. Okay, no part is recurring. So this is not a terminating, neither terminating nor recurring. These kind of numbers are called irrational numbers. For example, root 2. If we are taking root to 1.4142 up to so on, so we don't know what is the next part. In the recurring part, we can expect what is the next part, but in a non-recurring, we can't expect the next one. So this is neither terminating nor recurring, so it is irrational number. So root 3. So this is also irrational. Root 4. It is not irrational. Root 4 equal to 2. So 2 is integer. 2 is integer. So 2 is rational. Okay. So irrational numbers. The collection of rational and irrational numbers are called real numbers. The union, the collection of rational and irrational numbers together is called real numbers set. Okay. Next, between any two real numbers there exist infinitely many real numbers. Between any two rational numbers there exist infinitely many rational numbers. Okay. Next, if we are taking sum of any two rational numbers, we are getting rational. So sum of any two real numbers. 5 is real number. Root 3 is also real number. So 5 is rational, root 3 irrational, but both are real numbers. If we are adding these two, 5 plus root 3. So 5 plus root 3 is also real number. Adding any two real numbers, we are getting again real number. Okay, multiplying any two real numbers, we are getting again real number. Next, one more. So here, which part is repeating, which part is not repeating. For example, 17 by 32. So I want to check whether this number is terminating or not. So how do we do? So what is the denominator here? 32. 32 I want prime factorization. 2 into 16, 2 into 8, 2 into 4, 2 into 2. If we are doing prime factorization, 32 equal to 2 power 5. So it containing only prime factor 2. Definitely it is terminating decimal. If we are doing a number p by q form to decimal form, so without doing p by q form to decimal form, we can judge it is whether it is terminating or non-terminating recurring decimal with the help of the denominator q. If the denominator q has only prime factors 2 and 5, then it is terminating. Otherwise, it is non-terminating. Okay. For example, 17 by 40. I want to do prime factorization 40. 2 into 20, 2 into 10, 2 into 5. So what are the prime factors? 2 and 5. 2 and 5 are the only prime factors, so definitely it is terminating. So I am not done into decimal conversion, even though I knew this is terminating decimal. And next, 17 by 75. If we are taking 75 prime factorization, 5 into 15, 5 into 3. So what are the prime factors? 5 and 3. So if it is prime factor 5, no problem, but if it is 3, so it won't be 17 by 25. 75 is a prime factors are 5 and 3, so it is neither terminating, it won't be terminated decimal. So this is the some basic concepts about real numbers.